Thank you for joining me. We're going to talk about limits. We're going to run through a couple examples, and this is going to be an exhaustive list by any means, but just a kind of basis on a few limits. I've already done another video on an introduction to limits, basically what they are and what they do. I encourage you to go watch that one first and then come back to this one, but you can do them in any order you really wish to. So let's just kind of jump in. So let's start with a function, and there are different ways we can evaluate limits. We're going to look at this from a couple different perspectives. One of them will be from a algebraic perspective, and then graphically, and then also using data tables. So let's just start with, say, x over x minus 3, something like this. Okay? And what does this graph look like on a number of different things, right? And we can look at lots of different ones. So let's just start with something simple, like as the limit as x goes to, say, 10 of f of x, which is the same thing as saying the limit as x goes to 10 of x over x minus 3. Now, sometimes with limits, what we can do is just take the number that's right there and just plug it into the function we have, or the expression we have. So this is 10 over 10 minus 3, which is 10 over 7. And we can write the decimal equivalent of that, but we don't have to. We don't have to go through that process to do that. And that is really all we need from there, right? So this is our value that we end up with, 10 over 7. But what else can we do with that? I mean, what does this really mean in terms of what we've just found? Well, one of the biggest pieces it means is that when we want to have an idea of what this graph or what this function is tending towards, as x is tending towards 7, the y values are tending towards 10 over 7. So as x tends towards 10, the y tends towards 10 over 7. And we can see this very nicely by looking at the graph of this. And there are a number of different ways you can graph this. You can grab your graphing calculator, you can go to Desmos, however you want to do this, but I'd strongly encourage you to use that tool that you have accessible to you to look at what this looks like. Okay, and I'm doing this on my phone just real quick so you can kind of see what it looks like nice and pretty, right? And this is the spot we're really kind of concerned with, so I'm just going to kind of focus on that. I'm just going to redraw this because it's going to be useful to us here in a moment. All right, now there's what we call an asymptote right there. I didn't draw that very well. It's kind of curved looking, but it should be a vertical line right there. And this vertical line is actually at x equal to 3. And if you think about, and we're going to talk about this here in a second, but if you look at this function right here at 3, this function is undefined at 3. It's actually a domain restriction. We can't plug 3 in. We would get 3 over 0, which would be undefined. We can't do that. But at 10, right here, this spot right there corresponds with 10 over 7. So this is the point 10 and 10 over 7. Okay. Now in this instance, it's kind of like thinking about it. If you had you and your dog, are y'all going to meet up, right? And if you're both headed towards 10, which was maybe 10 to the park or whatever, are you going to meet up at the park? Sure enough, you're going to meet up at the park at 10 over 7. That's the height, if you will, the y value corresponding to that you'd meet up at. So in this instance, yes, you'd meet up. And that meetup place is 10 over 7. I'm not trying to overtalk this idea, but it'll make more sense here in a second when I look at another example. So let's do another one. Let's do the limit as x goes to 3 this time of x over x minus 3. Now in this instance, if we plug in 3, like I've already talked about, we'll do 3 over 3 minus 3, which gives us 3 over 0. Now some of you are going to say, well, the answer here is undefined. All right, this is not the symbol for 0, this is the symbol for undefined. Some of you are fond about putting a slash through that. And when we're talking about sets, that would actually mean the empty set, not 0. when we're talking about in terms of the answer to an expression or an equation or something like that. We're saying this is undefined. It's not zero, which is different. And what this means is do more math. A lot of times I write that as DMM. Okay? Do more math. Some people think, well, that's the answer. No, that is not the answer. That is a symbol to tell you to do more math when you're dealing with limits. Anytime you get a limit and you get undefined as an answer, that's not your answer. That is telling you do more math, right? Okay, that's what that means. So we do more math. What does that mean? How do we look at this? Well, let's go back and look at the graph. In this instance, let's think of this way. Here's you on that curve. Which way are you heading? If you're heading towards 3, you're actually headed that way, right? Here is your other dog, right? Fifi. This was Toto. Here's Fifi. Fifi's also headed towards 3. Are you and Fifi going to meet up? Are y'all going to meet up at the park? Nope. Nope, you're not. Because Fifi is going off this way. So Fifi's limit, if you will, is negative infinity, as opposed to your limit, which is positive infinity. Y'all aren't going to the same place. So what does that mean? It means that the limit as x goes to 3 of x over x minus 3 has 2 pathways. It has the limit as x goes to 3 of x over x minus 3 from the negative side, and we have the limit as x goes to 3 from the positive side. And really maybe a better way of saying that is from the right and from the left. Backwards though. This is from the left side. This would be from the right side. Okay. Okay. Now, that we can do. The limit from the left, negative infinity. The limit from the right, positive infinity. They're not the same, are they? Which now means we do actually have an answer. The limit as x goes to 3 of x over x minus 3 does not exist, which is a answer. What a lot of times we normally write is D N E. Okay? Okay, does not exist. We don't know what there is no limit to this. It's not, and keep in mind, we're not saying we do not know what the limit is. We're saying there is no limit. It's a very big difference between those two things. Up here, when we got undefined, we said we don't know. This is what this meant is we don't know. We need to do more math. We found that it's negative infinity from one side, it's positive infinity from the other side. So now we know the limit. The limit doesn't exist from both sides because it's going to different locations. Now there's a third scenario that I want to talk about here with this one. Okay, just in this one problem. The limit as x goes to infinity. Okay, and we could also talk about negative infinity, but in this case we're just going to do from positive infinity. And in this instance we're saying as x goes to infinity, okay, of this function, what is going on with it? All right, what's it doing as we move further and further and further and further to the right? What is it doing? And some of you might say, well, looking at the graph, it looks like it's going to 0. But is it? Okay, so this is where a graphing calculator is extremely useful to us. Okay, so here's that graph again. And what I can do is I can just start zooming in and zooming in and zooming in. And I'll cancel that. And this one's nice because since it's on my phone like this, I can actually just pull this way. And I'm not changing the x coordinate at all. I'm just changing, strike that. I'm not changing the y coordinate at all. I'm just changing the x's. And as I do that, you can see, and I can even zoom in this way a little bit, you can see I'm dealing with really massively huge numbers at this point, and my y value is still 1. All right? And some of you are like, whoa, how is that happening? Well, so let's dig a little bit deeper on that. So we plug infinity in, we get infinity over infinity minus 3, okay? And they're like, oh, well, infinity minus 3 would be infinity, so that's just infinity over infinity, which is 1. Yeah, it'd be nice if it worked that nicely, but it doesn't always work that nicely, so we have to be really careful when we deal with this. Let's go back to the original problem, okay? The original problem here, when we looked at this, we have x divided by x minus 3. So we do the long division on this, and we get 1 times x gives us x. Subtract that off, and you have the minus 3, of course. You do that subtraction, and you get 0, and then minus 3. Here's your remainder, right? Which means that this is your horizontal asymptote. Okay, and we know that because the remainder is a number, not an expression, but it's a number, which means that this value we got up here, whatever this is, strike that. Since this value up here has no variables in it, this is a horizontal asymptote because we got down to the remainder. The remainder just simply means that we're done. This piece right here is a horizontal asymptote, so this is y is equal to 1 as my horizontal asymptote. Well, a horizontal asymptote tells us what we tend towards at extreme values of x. So as x goes off to infinity, this whole thing goes to 1. Here's a whole nother way to look at this. Okay, and some of you are going to be like, that seems like cheating. You're not wrong, but we still do it because it works. Okay, so we're going to do the limit as x goes to infinity of x over x minus 3. Here's a whole nother way to think about this and work this through. As x goes off to infinity, really what you're concerned with, what are the extreme behaviors, the extreme right behavior or the extreme left behavior if you're looking at negative infinity. How much behavioral effect is this minus 3 going to have on the overall function? Practically none, okay? At really huge values of x, what's going to have the biggest impact is going to be the leading coefficients of the numerator and the denominator. So we can think of this, I put an equal sign there, but really what we should think about is maybe more of a congruence or an equivalence even. The limit as x goes to infinity of x over x, which is the limit as x goes to infinity of 1, which is 1, okay? And that's how we're going to think about that. It makes it a lot simpler when we think of it in those terms because it's this leading behavior that's going to make the difference, but only when we're dealing with x going to infinity. More videos on this later, and we'll also talk about this in class for those of you who have me for a course. All right, thank you. Bye-bye.